This is a Sphyinx 300 kit that we're working on. It's a 72 millimeter bore, and this particular cylinder is going to run with the stock stroke. It does require the 87 and newer 130 millimeter rod length. They just don't work with the short rod. These cylinders are primarily designed for high RPM drag racing applications. So we buy the cylinder and we buy it longer than it needs to be so we can change the port heights by machining off the base of the cylinder. So this one here is we've cut the deck so we get the port timings where we want it. And now we're going to, basically we're lowering the exhaust port height. And so now we're cutting the transfer ports so that the transfer port window widths, which are these right here, we make sure that these port windows are the correct width, make sure they're angled in the right directions for the application that we're building for. And then we will have to also change the shape of the exhaust. So we're going to make the exhaust port lower, but we'll make it wider. And the purpose of doing this type of porting is because this particular application is going to go to someone who's going to ride in the sand dunes. He's not going to drag race on flat ground. He's going to trail ride, he's going to play ride, and when he drag races, he's going to be drag racing up the hill. So it's really critical that the engine pulls when he shifts into the upper gears. It needs to pull fourth gear hard when he shifts, or he'll run out of top speed on the hill. If the engine is too pipey, you'll get stuck in the gear. No matter how you gear it, you'll get stuck in a gear that's too low to carry speed over the top. So the engine will be revved out, you can't accelerate anymore, but if you shift to the next gear, it'll bog. So with this type of porting, you can handle paddle tires, which have a lot of drag, and you can pull a relatively heavy machine, quads are heavier than motorcycles, and still pull the gear so you can shift till you're to the top of your hill. So the porting for this type of power, we're looking for a lot of power. We want to make, mid 50s kind of horsepower. We want to make 55, 56 horsepower. So the porting has to be extremely precise in order to get the peak horsepower that we need and still have the kind of mid-range, low-end kind of power that will make this thing accelerate up the hill and pull really good on the trails. So that's different from drag racing on flat ground with an override transmission. We really have to be able to pull when the engine drops in RPM at each gear shift, especially the upper shift. And when you hit that kind of power, the bike becomes extremely fun to ride. This is what really makes them fun, is because you can shift it early on the hill, or you can torque it around on the trails, and it's still fast, and it still pulls, it doesn't bog. So we're going to, so what we're doing right now is we're finishing the porting up. We've got to grind the casting flash out of it. This cylinder comes pretty rough. It's really a quality cylinder, but there's still some casting flash and things left in the cylinder that we prefer to take out ourselves. And then the transfer ports, we'll finish the transfer ports, we'll grind the ducts so that they flow good, so that they flow equally. Each transfer port needs to match the opposing transfer port. So you have three transfer ports that are directly across from each other, and each one of those three ports needs to flow the same as its corresponding port on the other side of the cylinder bore. So you can see how the transfer ports, these transfer ports on the side, this transfer port on this side needs to match flow rates with that transfer port so that it pushes the fuel charge to the center of the cylinder. And so you have to be really careful how you cut those ducts. You have to be careful how they are angled. And then we also, the rear transfer port, which is this one here that points up, it's really critical for guiding the scavenging up the back of the cylinder wall. And so we've changed the height of that one as well. And so next we'll go to work on, now when the transfer ports are all done and ground so they flow properly, See, we still have some casting flash to grind out of there. Then we'll go to the exhaust port and we'll change the shape of the exhaust port, and we're looking more for width than we are height. Here's the cylinder after the porting has been done. So the porting changes that we've made, as we talked about before, the transfer ports are all matched, cut to the proper heights. The exhaust port shape is now different. This is the exhaust port right here with the proper widths, proper heights. And then the auxiliary exhaust ports, which are these two boost ports right here. These are also exhaust ports, and they are also set to the proper heights and widths. And now the next step that I'm going to show you is how we cut the base of the cylinder. So this cylinder was a little bit longer than needed. That's the way we buy it. So what we do is we have a mandrel that goes in the bore, and then it cuts the base, it allows us to cut the base of the cylinder so that the cylinder base is perpendicular with the bore. And so doing that, we can lower the whole cylinder, which lowers all the port timing. So essentially we're trying to get the exhaust port height where we want it for the type of riding that we're doing. And then the rest of the porting, of course, allows us to correct the transfer ports, which will then be too low. So we'll raise them back up, just like I've shown you in the earlier frames. So now to the mandrel. So this is the mandrel that we use for turning the cylinder. We have a sleeve that goes inside the cylinder. This sleeve inside. This all slips down like this. Lock it in place. We go in the lathe, and then it's supported on the tailstock. Now the lathe will turn the cylinder, and we can cut this base so we get the cylinder to the proper length.